Hello, welcome to this short presentation on milestones in Canadian housing. This presentation was created by the Net Zero Energy Housing Council of the Canadian Home Builders Association. How appropriate is it that we talk about milestones in Canadian housing when Canada, the name itself, actually means a village, settlement, or a collection of huts? During this presentation today, you will see how Canadian home builders and Canadian building industry has been able to do an excellent job at building some of the best cold climate housing in the world. Today's presentation will cover Canada's relationship with wood, Levittown, the Victory Homes, Canada's National Building Code. We'll talk about the Saskatchewan Conservation House, the Saskatoon Energy Showcase, the Super Energy Efficient Housing Program, an R2000. We'll also look at the Healthy Houses Program and the Advanced Houses Program. Then we'll speak about equilibrium homes, net zero homes, net zero renovations, and we'll take a quick look at what the 2030 National Building Code is expected to have. As I mentioned, Canada is a world leader in energy efficient housing construction. We build the best cold climate housing in the world. Other countries from around the world have come to Canada to see how we do what we do. And it's not by accident that we build the best houses. We've got 80 years of extensive research has gone into energy efficient construction in this country. We've had government and industry working together to create demonstration projects that showcase some of the advancements and the improvements in energy efficiency. And over the years, we have constructed many thousands of energy efficient homes. In the early days, the early settlers arrived in Canada and they saw lots and lots of wood, huge trees, forests everywhere, and it was natural that those pioneers would start to build with wood, building log homes and eventually sawmills and creating dimension lumber. Wood has proven to be a very durable product for Canadian housing. Here you see an 1850s house. These houses are still standing today. And of course, modern day houses still incorporate wood. And we've learned even more ways to make the wood more durable and last even longer. Now, one of the first things I'd like to talk about to set the stage is a place called Levittown, New York. Now, this is not a Canadian milestone, but nonetheless, it is still an important development in the building industry. If you can imagine, prior to World War II, all houses were custom built. So every house was different, every house had a set of plans, and the builders put together each house according to those plans. Now in 1947, there was a young builder by the name of Levitt. He was actually the son of the Levitt and Sons builders in the United States. He was attached to a battalion of the U.S. military called the Seabees, or Construction Battalion. And their job was to build the camps. So they assembled the camps, they tore the camps down, they moved the camps, they reassembled the camps. And they were able to do this very quickly. And he had the idea to apply this technology to the housing industry when he got home. So he convinced his father that a good idea would be to build houses that had a standardized design, use the same standards for all the houses, to break these projects into small steps, use specialized crews, so concrete guys, framers, drywallers, electricians, plumbers, that type of thing. Reduce the total number of steps to building a house. Use the fact that you're building many, many houses to apply mass purchasing principles to the materials so that you can get the materials for less cost. And the result of these changes to the building industry resulted in what we now know as tract housing. So essentially what they did was they brought factory processes to the job site. Canada had its own need for many houses after the war, and Canada's effort in the area of tract housing was what we called victory homes. So Canada had veterans returning from the war, and they needed to be housed. They wanted to have families and get on with their lives. So these houses were created all across the country. Typically, they were 1.5-story houses, about 1,200 square feet. And over 1 million of these houses were built between 1945 and 1960. In many towns across Canada, you can still see these houses standing today. Many have been renovated, of course, but those houses are still there. The early houses had 2x4 walls, many of which were uninsulated at the time, and the best window technology that was available was single glazed windows. About the same time, or just prior to the end of the war, Canada's first national building code was created in 1941. And there's a picture of the first building code there on the right-hand side. At that time, the housing across Canada was different in every province and every territory. So let's just take a minute and talk about how legislation and regulation surrounding housing works in Canada. The provinces and territories are responsible for housing legislation within their province or territory. So at the end of World War II, there was no housing uniformity across the country. There were different rules and regulations for building houses in each province and in each territory. Now, the National Research Council looked at this and felt that that was a large waste of time and resources, that every province was putting effort into creating their own code. So the National Research Council put together what is known today as the Model National Building Code. And this was done in an attempt to harmonize the building standards across the country. And keep in mind that the National Building Code, or the Model National Building Code of Canada, has no basis in law. It only has a basis in law once the province or territory adopts it as their provincial or territorial building code. So in the 1970s, and in particular in 1977, during the early 1970s, it was believed that the world was running out of oil. And as a result, energy prices were going up. There were shortages of fuel oil and gas for operating vehicles. And countries around the world started to focus on how they would reduce their energy consumption in order to conserve the oil that was still available. And in 1977, the National Research Council, and in particular a legendary building person in Canada by the name of Harold Orr, decided that they would build something called the Saskatchewan Conservation House. This would be a demonstration project to show how we can build houses that use very little energy. They decided on a number of the parameters, but one of the parameters was the air change rate. So they decided on 1.5 air changes per hour at 50 pascals depressurization. And how did they come up with that number? Well, that number seemed like it was a good, reasonable target at the time. Now, remember that blower doors were not readily available in 1977. And the National Research Council actually had to design and build a blower door just to test this house. So based on testing of other houses, they had found that, the number was 3 or 2, and so 1.5 was chosen because it was a little bit ahead of what they had been able to achieve on other houses. So let's have a quick look at the Saskatchewan Conservation House. The house was built on piles, so the floor was exposed. So they built the floor with an R30 amount of insulation. The walls are 40, the ceilings are 60. Now, remember in those days, the windows were not the same quality as what we have today. So a window was typically R1, maybe R2. So the designers and the builders of this house recognized that the windows were essentially thermal holes in the building envelope. So what they designed into the house was insulating shutters. So in the daytime, sunlight could pass through the window glass and passive heat could warm the house. And at nighttime, they could close the shutters, making the windows much more insulating at a level similar to the walls. So they designed insulating shutters of R22 for the lower floors and R14.5 for the upper floors. They equipped this house with solar collectors, and as I mentioned, they used passive solar through the windows. They also had gray water heat recovery. So they were collecting the waste energy from the gray water and recycling that energy to preheat domestic hot water. Recognizing that the house was going to be energy tight and relatively airtight, they also knew that an important feature was going to be the ventilation to keep people healthy. So at that time, they designed and built one of the first heat recovery ventilators in Canada. And the heat recovery ventilator was built from plywood. So based on the success of the Saskatchewan Conservation House, the Saskatoon Energy Showcase was born. Now remember at the time, or think about at the time, that there was a number of naysayers who said, look, it's all fine and good that you can build one of these houses. And you can do a great job when you have unlimited time and unlimited money. But the Canadian building industry said, no, it's not just that we can build one of these. We believe that we can build a lot of these. And so the Saskatchewan Energy Showcase was undertaken in 1980. And the way it was done was they found 14 builders who were willing to build houses like this. They put on a weekend training session for these builders. And they taught the builders about the importance of insulation, about the importance of air tightness, and about the house as a system, essentially. And when these builders left that training session, they went out and they built 14 homes, and these were constructed to demonstrate the state of the art of energy efficient technology. And all of the houses were able to achieve 1.5 air changes per hour at 50 pascals. And what that did was it demonstrated that the industry could do it. The Canadian building industry is able to build high performance houses. They need to be shown, they need to be trained, but the industry, once they had the knowledge, was able to do it. These houses were performance monitored, and they provided the technical background for the development of R2000 and the R2000 technical requirements. The forerunner to R2000 was the Super Energy Efficient House Program, and that was established in 1980 by Natural Resources Canada. At that time, they were called Energy Mines and Resources, but today they still go by the name NRCan. R2000 was launched in 1982, and it was a joint effort between NRCan and the Canadian Home Builders Association. The technical standards for R2000 were based on solid building science principles. That was really where the house as a system concept was born. It was the house as a system concept that set Canada apart from other countries in the world. Other countries would look at the house as a collection of components: building envelope, mechanical systems, plumbing systems, wiring systems, heating, cooling, ventilation. The Canadians looked at the house as a system. When you change one part of the house, like the building envelope or the mechanical system or the air tightness, it changes the other components of the house. They change as well. And the house as a system not only includes, the building envelope, the mechanical systems, but the climate as where the house is located. And it also includes the interaction with the homeowners and the people who live there. Now, the energy features for R2000. So R2000 sets a target for each house. And the way that you determine whether or not the house meets the target is an R2000 plans evaluator would evaluate the house using a program called HOT 2000, a computer simulation. The builders for R2000 houses were all trained. So R2000 builders took specialized builder training, and that was the first step. Then they had to build a demonstration home. They had to build a house that met the R2000 technical requirements prior to them being able to call themselves R2000 builders. So each of the homes was independently inspected and certified. The energy consumption for these houses was typically 60% lower than a code-built house. So these houses were performing 60% better than the code-built houses across the country. The marketing program was delivered by Natural Resources Canada, and there was over 10,000 certified R2000 homes built over the life of that program. Now, that doesn't sound like a lot of houses when Canada is building roughly 200,000 houses a year. 10,000 houses doesn't seem like a lot of houses. But the reality of it is that R2000 builders and left a very big imprint on the building industry, because the rest of the industry was watching to see what R2000 builders were doing. And through the trickle-down effect, that technology started being incorporated into all the houses in Canada, and the building code actually stepped up each time it was modified to include some of these technologies. There's not a house built in Canada today that does not have some of the features of R2000 in it. And one of the key things about R2000 was that R2000 was not a prescriptive standard. R2000 was a performance standard. And so the target that was presented to the builder to hit did not stifle the innovation of the builder. Basically, here is the energy number that you need to get there any way you can. And as a result, the Canadian building industry rose to the occasion, and there was a lot of ingenuity, there was a lot of technical advance happened in order to create the products and the materials and the building techniques that we have today. So when we look at the R2000 program, the technical requirements were that the insulation levels were determined based on HOT 2000 energy analysis or by local prescriptive standards. So you could not use insulation that was less than what might have been in a provincial building code or what might have been in a local city bylaw. There was high energy efficiency, sealed combustion, or induced draft equipment. So basically the best mechanical systems that you could buy at the time. The air tightness of 1.5 air changes per hour at 50 pascals. You may recall that from the Saskatchewan Conservation House, the target was also 1.5. The Saskatoon Energy Showcase demonstrated that all the builders could hit 1.5. So 1.5 was chosen, 1.5 or less was chosen as the air tightness for the R2000 program. These houses also needed distributed mechanical ventilation because we knew that when you build houses tight, that you need ventilation for the occupants. Later in the R2000 program, there was environmental features added, there were indoor air quality features added, and the R2000 standard was updated roughly every 5 years. With R2000 focusing on energy efficiency and environmental responsibility and using ventilation to control indoor air quality, CMHC launched a program called the Healthy Houses Program. And that was roughly in June of 1991. And the concept here was that, yes, we know that when we build houses tight, we have to ventilate to provide adequate ventilation for the occupants of the house, but we're also ventilating to get rid of chemicals that may be off-gassing from building materials. So the Healthy Houses program was intended to look at, wouldn't it be nice if we used products in the house that don't off-gas? So let's create a house where we don't need to ventilate for the removal of contaminants. We only need to ventilate for the health of the occupants. And so the Healthy Houses program was introduced to look at that. It was a national design competition to promote housing with low environmental impact and using healthy indoor materials. It introduced this concept of healthy housing design principles to the housing industry. So they launched the competition. There was 2 winning entries constructed and used for demonstration purposes to show the Canadian public how this could be done. So if we look at these, let's look at the first one, which was in Vancouver. So that was called the Vancouver Healthy House. It was an infill unit that was placed behind existing upgraded house, increasing the urban density. So it looked at how do we increase urban density and create healthy housing at the same time. It used half the energy of an R2000 house, so it was super insulated. It was very resource efficient. They used all low toxicity interior finishes, cellulose wall and ceiling insulation, so environmentally responsibility, it was demonstrated using recycled product. They used high efficiency particulate and chemical absorbing filters. So in addition to putting in low tox materials, they also used filters to filter out anything that might be there. They had a low tox HRV system, and they incorporated solar domestic hot water as part of their energy efficiency aspects of the building. The second Healthy House winner was called the Toronto Healthy House. The interesting thing about the Toronto Healthy House was that it was completely independent of municipal services. So all the water that was used was supplied by rainwater harvesting and through water treatment of the wastewater. The house was heated using passive solar heating. It had a photovoltaic array, as you can see from this picture, and it also incorporated solar domestic hot water to reduce the energy of water heating. Following on the success of the Healthy Housing Program, the Advanced Houses Program was launched by Natural Resources Canada in partnership with the Canadian Home Builders Association. The technical specs for the Advanced Houses Program were that these houses needed to use half the energy of an R2000 house. They were to incorporate innovative and environmentally benign technologies. They were to use recycled materials. They were to reduce the water consumption by half, cut the water consumption by 50% over conventional houses. There was a requirement to use construction waste management techniques in order to reduce the amount of waste going to landfill sites from construction projects. Indoor air quality guidelines were set, and the houses needed to meet these requirements. There were proposals requested, and from the proposals that came in, there were 10 teams selected to build advanced houses across Canada. In order to keep these houses looking like they belonged in subdivisions or typical Canadian housing, there was a requirement that the houses had to be sold and that those houses needed to be monitored for 1 year with the occupants. As I mentioned, there were 10 advanced houses. Here is a snippet of 5 advanced houses from across the country. The BC house used a lot of recycled materials. The Ottawa house, for example, was the only house in the program that had been built by a Tract builder. The Waterloo Region Green Home was able to reduce typical construction waste from 2.5 tons per house to 2 green garbage bags. They did that by using a lot of prefabricated and materials that came to the job site so that there was no waste created at the job site. Recapping the Advanced Houses program, some of the sample technologies that we saw demonstrated in these 10 houses across the country was the use of prefabricated stress skin wall and ceiling panels. We saw a variety of engineered wood products used, from finger jointed lumber to wood eye joists to open web floor joists. We saw engineered wood products stood on their end to become thick walls, so the adequate amount of insulation could be put in there. We saw home automation systems being introduced into many of the houses. This was largely to fine-tune the mechanical systems and make the mechanical systems squeeze every last gigajoule out of energy efficiency out of the house. We saw radiant ceiling panels used for cooling. Photovoltaics, of course, for solar electric systems were installed on all the houses. We saw a new technology called a light pipe. The light pipe was an alternative to the conventional skylights which are used in houses. We saw truss walls with cellulose insulation. We saw a sealed combustion gas stove. So for those of you think about the gas stove, it's a spillage guaranteed appliance. What one team did was they took a conventional gas stove, put a ceramic top on it, and then vented the space where the flame was located to remove the combustion gases from the house. We saw solar domestic hot water systems coupled with photovoltaic powered pumps. And what this did was it matched the fluid flow to the amount of solar energy that was available. So as the sun became brighter, there was more energy available for the heat transfer fluid to absorb. The pump sped up and moved the fluid faster. So it was ideally coupled to match the sun. We saw the first integrated heating, domestic hot water, ventilation, heat recovery systems being combined. So the first combo type systems. And when you think about this, you recognize that the designers were saying to themselves, well, look, we've built a house that uses very little energy. Why would we put in a furnace and a hot water tank, for example, to provide that energy? Why couldn't we put in a hot water tank and put in a fan coil unit to provide the heating for the house? So make the hot water tank do double duty. It provides the heat for the hot water and it provides the heating for the house. So using house as a system thinking, we are now starting to see the combination of mechanical systems in order to meet the loads. Following on that was a program called Equilibrium Housing. That was done by the Canada Mortgage and Housing Corporation. It was a national residential design build initiative to challenge builders to design low impact, affordable, healthy, highly energy and resource efficient housing. It resulted in low to no housing related environmental impacts on the land, the water, and the air. And these houses were built to facilitate public demonstrations. There was performance monitoring, and there was reporting on all of these houses. Now, the Equilibrium houses became the forerunner to the Net Zero program. The Net Zero program is run by the Canadian Home Builders Association, and it was started in 2015. as of the end of 2020, 620 homes have been labeled in total. 428 of those homes have been labeled to the Net Zero Ready standard, meaning that they are only missing the photovoltaic panels and the generation capacity. 192 of those homes have been labeled as full net zero, meaning that those houses produce as much energy as they consume over the course of a year. I think it's important to take a minute now and think about the significance of these 620 houses that have been built under the Net Zero program so far. Since 2015, we have had leaders in the building industry who have been constructing these houses voluntarily to the Net Zero and the Net Zero Ready standard. In the 1960s, a 2,000 square foot house built in the city of Ottawa was consuming approximately 342 gigajoules. These net zero houses for the same size house are using approximately 40 gigajoules. Now that's a pretty significant reduction. And as you can see from the graph on the left, it wasn't all done in one big step. It was done incrementally, decade by decade, to get us to the point where we can build a 40 gigajoule house today. This is important because we are expecting that the 2030 National Building Code will be requiring all houses to be approximately 40 gigajoules at that time. And we have successfully been able to demonstrate that we can do that today. With the success of the Net Zero program for new homes, the logical next step was Net Zero renovations. So the Net Zero Housing Council has launched a Net Zero renovations pilot program. So the pilot program is slightly modified technical requirements from the new program, and these modifications were made based on practical considerations. So, for example, there is not a requirement to provide sub-slab insulation because the slab is already there. If there's enough headroom in the basement, of course, it does make good sense for the builder and the designer to specify insulation on top of the floor and put in a new subfloor so that the floor is, in fact, insulated. The rim joists, again, one of these areas that are not very accessible in an existing house, they do not need to be insulated to meet the same R value as the wall above grade. Now, keep in mind that the targets for net zero renovation in terms of energy efficiency and an energy target, these are all the same as for net zero new houses. So the energy efficiency in the reno does have to be made up somewhere. Now, we know that fireplaces in conventional housing and conventional fireplaces are net losers of energy to that house. So a fireplace in the best conditions are energy losers, and in the worst conditions they can be dangerous if there is backdrafting. So fireplaces need to be decommissioned or sealed, and the house must undergo testing to demonstrate that it's not backdrafting. Ductwork, if the ductwork is not fully replaced, then the accessible portions of that ductwork must be sealed. And that is described in the technical requirements as well. So one of the things that we have learned from our net zero housing work is that it's very important that the heating, ventilating, and cooling air gets to each room according to the requirements of that room. So if the ductwork is leaky, the air does not necessarily get to that room, and we end up with hot or cold rooms in the house. And of course, for net zero housing, the comfort and control of that house is very important. And getting the air to where it is supposed to be is a key consideration in maintaining that comfort level. So the ductwork needs to be sealed. And so the 2030 building code is expected to mandate that all new houses in Canada will meet at least the net zero ready standard of housing. And so this diagram illustrates how we're going to get there from 2017, when the net zero program was launched by the Canadian Home Builders Association, until 2030. So the model, net zero energy ready codes for building and houses, were demonstrated or created in 2017. The building code is expected to be ratcheted up. So the building code is updated every 5 years. So it's expected that the building code will move forward, that it will be tiered in order to improve the energy efficiency of housing. So by 2030, all new houses will meet net zero ready. There's been research and development is ongoing right now in order to lower the incremental costs of building to net zero. So the net zero program has been able to demonstrate that the Canadian building industry is perfectly capable of building houses to this level of energy performance. The challenge now is to be able to build these houses at scale, meaning 200,000+ houses per year, and do that in a cost-effective manner so that Canadians can afford to buy these houses. And so, this is where we are. And now, this concludes this presentation. But it's not the end of the presentation. This will be continued. I'm sure that there are many more Canadian milestones that will follow in the years ahead. And hopefully, some of you listening to this presentation will be the ones who create those milestones. And we'll be talking about the work that you've done over your career and the houses that you've built. And a little quote that I'd like to end with that I've always found useful is the reason we can see so far is because we are standing on the shoulders of the giants who came before us. So those people in the 1970s who could see the future, they knew where we had to get. And if you look at the Saskatchewan Conservation House, the insulation levels in that house are basically the same as the houses that we are building today to the net zero level 50 years ago. Thank you very much for listening to this presentation. I hope you enjoyed what we had to say. And for more information, the contact information for the Net Zero Energy Housing Council is shown on the screen, along with other information sources that you can reach out to. Thank you for listening, and goodbye.